Hello students, how are you? We are here in the question 3. It says in the figure opposite, I is a current flowing through a circuit. What is the charge that flows through the circuit for the first 0.7 seconds? So I have this figure here. It's a graph of the variation of current in ampere and the time in seconds. I see here various numbers, the variation between current and time. The question is about what is the charge that flows through the circuit for the first 0.7 seconds. I notice here this is the second. I'm sorry, I didn't let me use a pen. Okay, with the red. Okay. So the question says, what's the charge that flows through the circuit for the first 0.7 seconds? I notice here that when the time is 0.7 seconds, I notice here that the current will be 6 ampere. In here, it's 6 ampere. So I need the charge, which is given as we know, charge equals to current multiple time. So basically by substituting the numbers, I have 6 multiple 0.7. I will get the answer, charge equals 4.2 coulomb. And that's how I can find the answer of this question. The next question is here. The question says, copper wire of cross-sectional area 3 millimeters squared carrying a current of 5 ampere contains 8.5 multiple 10 to the power 28 electron per meter cubic. What is the magnitude of the drift speed of the electrons in the copper wire? First of all, we need to write the information that we have. We have here 3 millimeters squared, which is actually the area. Okay, I need to remember that area should be always in meters squared. So I directly change. I know from before that when I want to change from millimeter to meter, I divide by 1,000. But here it's from millimeter squared to meter squared, so I divide by 1,000 squared, which is a million. So it's basically like multiplying by 10 to the power negative 6. Okay, this is the area in meter squared. Okay, this is the first information. Then I have 5 ampere of current, so I have the current is 5 ampere. Okay, this number here, they say, contains 8.5 multiple 10 to the power 28 electron per meter cubic. This is actually the number density. We remember the number density, we said it's the number of electrons per unit volume. So this is the number density, 8.5 multiple 10 to the power 28 electron by meter cubic. You can find the unit as 1 by meter cubic, or you can see it in another form, which is meter to the power negative 3. They are asking for the drift speed or the drift velocity. I know from before, I have the formula I equal number density multiple area multiple the drift speed multiple the charge of 1 electron. And of course I know the value of this charge of electron. Let me write the number in here. E equals 1.6 multiple 10 to the power negative 19 coulomb. Okay, so if I want the drift velocity or the drift speed, whatever you want to call it, it's actually current multiple divided by, I'm sorry, number density multiple area multiple E, and I will get the answer. So I got the answer here, 1.225 multiple 10 to the power negative 4. So the correct answer is actually here. The correct answer is this one, which is 1.23 multiple 10 to the power 4. So this is the correct answer. I hope it's clear. If you have any question, please leave it in the comments below.